All right, question 30 says, use Cavalieri's principle to compare the volume of the two solids. So the first thing we need to know is we need to know what Cavalieri's principle is, or what it says. And it says that if two figures have the same height, and they have the area of a cross-section is the same, then they're going to have the same volume. So let's talk about the area of a cross-section. That just means if you take this cube and you slice off a piece, so if we slice off this bottom rectangle right here, actually this bottom square, and we find the area of that, and then we come over here and we slice off a piece of this one, so we're going to slice off this little circle off the bottom, and we're going to find the area of that. If these two figures have the same area and the same height, then we can say that the volume is the same. So to figure this out, I'm going to find the area of each of these pieces. So first I'm going to go over here to the cube. So each side length is the square root of pi times radius. And to find the area of a square, or cube, I'll call it a square. Sorry, we're not doing a cube, we're doing the area of a square. We would do the side length times the side length times width. So I'm going to do square root of pi times r times square root of pi times r. And this is going to give me the area of this square right here, just this one cross section from the whole cube. Alright, a really cool shortcut is if you have the square root of pi times the square root of pi, the square roots cancel and it just leaves you with pi. And that works for anything. Like as a little side note over here, if you had the square root of 2 times the square root of 2, that just equals 2. And you can multiply that out to know for sure. Let's do one that we understand. Square root of 9 times square root of 9. That would be 3, that would be 3, and we know that 3 times 3 is 9. So this shortcut always works. And then if we have r times r, that would be r squared. So the area of this square, this cross section of the cube, is pi r squared. Now we're going to find the area of this cross section of the cylinder, which is a circle. And to find the area of a circle, you would do pi times radius squared. We don't have to do any simplifying there. It is just pi times radius squared. So we notice that both of these cross sections have the same area. And then we have to check and make sure that the height is the same on each. And both of these heights are also the same. So we can say that the volume of the two figures has to be equal. And that's using Cavalieri's principle.